Today's lesson is on section 9.3, finding special products of polynomials. So far in this chapter, we've added polynomials together. The table method and the FOIL method. Those will still come in handy in this section. This section 9.3 is also about multiplying polynomials when we're multiplying polynomials together. There are certain problems that we'll see them again and again, and if you know how the pattern works, you can jump right to the end. Some that looked like it that we did in chapter 8 just recently or so. I'm going to split the difference though and show you how they are two different things. (4x squared). This is a monomial, one term by itself here, because these are joined by multiplication. So that's a monomial. We learned in chapter 8, because this is joined together by multiplication, that I can actually apply this squared power just to both of these things, and that so 4 squared would give me 16, and x squared is just x squared, and that would work for a problem like that. Over here though, action or addition that's joining those two things, this is actually a binomial, as we've talked about. It's the squared power to each of them. That does not work. So realize for one, that is not at least that's not the full. Just by squaring each of those, there's something else I have to do. If nothing else in this section, one thing I'd like you to take away is that when you square a binomial, when you do this binomial and then it's squared, when you see this, the first thing you need to realize is this is how you write that. Squared, like up top here for a second. If I have x squared, what does that mean? That means that variable x times itself when I square it. So x minus 3 times x minus 3. If nothing else, the first thing I want you to realize, that's what it's talking about. Now from here, we actually know a way we could multiply this out. We could FOIL or we could use table method. I'll use table here to start. X 3, I can multiply, put those things on the top and the side, and I can multiply and fill in my boxes here. Also, and here I'll get positive 9. Negative 3 times negative 3 gives me positive plus 9. So just realize, yeah, I didn't get just an answer of squaring each of those things. I ended up getting x plus 9 for my answer. We're going to talk about in this section how I could shortcut. As soon as you see the square of a binomial, I can jump right to this answer, but I'll talk. Before I talk about that, I want to mention one more thing. Again, showing you like I did up here in chapter 8. Why this power of a product rule, that works for a monomial, but it doesn't work for a binomial. There's a few different ways maybe I could show you how that works. Here's a quick way. It's 3 and that's squared. And then let's say we actually know what x is. Let's say x is 5. Well, like you've done in many grades before now, and 5 minus 3 squared is just 2, and 2 squared gives me 4. So that's what we could get for an answer. Well, again, showing why this rule here, power do something like this, will give me the correct answer. If I do that, and again, showing you, yeah, this is wrong. This is something you can't do. But if I try to, and the negative 3 squared would be like positive 9, correct? And now if I say, well, x is 5, and I plug that 25, oops, kind of a fast 25 there, 25, plus 9, that would give me 34, which, yeah, is not 4 like we were looking for. So, again, there's just kind of an example to show you, yeah, it doesn't work mathematically. If you have a binomial, you can't just take each of those numbers squared with it. And really, this is the way, kind of like I showed you up here. Whenever you see a binomial squared, here's the first thing. If nothing else, that's the first thing I'd like you to realize, that that's what that's. So So again, in that first page I mentioned though that in this section we are still multiplying polynomials together. So look at a problem like I would have here. Let's say I was going to try to multiply those two binomials together. Again, we know two different methods. We know FOIL and table. And for this one, I've already started using the table here. 8x squared from this top left square. And then from these next two, I'll get 12x minus 10x. Those are my like terms. I can combine those and just get positive 2x. And then minus 15. So here's what I get if I multiply that out using FOIL or table method. Well, what we're going to learn, again, as I talked about a little bit on the first page, binomial squared, some binomial like 2x plus 3, and then that's squared, so to the second power. This pattern is a very familiar pattern, something we'll see again and again when you're working through higher levels of algebra. And sometimes you have to multiply all the time. There's a little shortcut that we could jump right to the answer just by being at this part of the problem. If I see this, there's a way you can jump right to what the result of multiplying those together is going to be. You could also still use FOIL and table method. They'll still get you the answer. We'll just use all the steps. So I'll show you that as well right now. Let's say this is your... Well, again, if nothing else, the first thing I want you to realize is that written out is really 2x plus 3 times 2x plus 3. So if you started no other way, that'd be the way to start. Realize that it's that same binomial times its methods. Again, table or FOIL. I'll do table here. Or sorry, FOIL method because I did table up above. I'll multiply x times 3, which gives me 6x. The inside gives me 2x times 3, which is also 6x. And the outsides is plus 9. So here's what I would get if I FOILed. And then collecting the like terms for a final result. So I had 2x to the third squared. And then I wrote that as, well, that means 2x plus 3 times 2x plus 3. Used FOIL, and then got to my final result. Again, that is that you can jump right from here to the answer if you notice that this is a binomial squared. And what the pattern is, there's a familiar pattern that always happens whenever you square a binomial. It can always get you right to this. I talked a little bit on that first page, but I'll kind of show you right now. When you're doing this, 2x plus 3, I told you that on that first page, and show you that example, that it doesn't just work, though, to take each of these things squared. Okay, that's not the full answer. But I will show you that that is actually part of what we get. So look at what happens when I do that. If I square each of these, 2x squared would be 4x squared. It would be 9. Well, again, that's not the final answer, but do look at it. I do see that 4x squared is right here, and this 9 is right here. So that ends up being part of it. But the only thing is I didn't account for this middle term. In class right now, I usually talk to students. I know, well, where does that middle term come from when I'm doing this multiplication? Again, this isn't the whole answer, so don't realize that's the entire thing of what you do. But yeah, part of the answer did just come from taking 2x times 2x. That gave me the 4x squared here. And then 3 times 3, I end up squaring that. And 12x also has to be accounted for, this middle term. So where does that come from? After a little bit of thinking, we'll kind of realize that, well, because this is a binomial squared, what's always going to happen, if you have to square some binomial, you're going to have the same number and here, right, for your first and your last terms. Well, then when the eye of FOIL, or sometimes it'll be like the top right and the bottom left box in your table method, what's always going to happen then when you're squaring a binomial is whatever you because no 6x. Adding those together, that gave me the 12x. Whenever you're squaring a binomial, this pattern's 4, 2x, 9, and then those two in the middle term ends up coming from when I take the outsides and insides and double it, same middle term. That pattern always happens when if you're taking notes along with me, here's what I'd like you to write down about it. And if it's still a little confusing, I understand, because again, I'm trying to teach you a shortcut when we're still even learning a little bit how to multiply polynomials. I promise. It's called the square of a binomial pattern. When that's squared, okay? Whenever you have some binomial squared and you have to multiply that out, there's a shortcut to get you right to the examples, but using the algebra, b squared, that first term, squared, whatever that is, b squared will be at the end here as well, so I'm going to square that. That'll be part of my answer. And the middle, like I talked about, so when you multiply AB times itself 2 different times. With the result, that's the pattern. That's what always happens when I square a binomial. So let's look at the result right here. So x plus 4 squared. So again, if you're going to do it the long way using the table method or FOIL method, you wouldn't necessarily have to know this shortcut. You could write this out though as x plus 4 times x plus 4. And gives me x squared. And x. And the last terms would give me 16. So I get x squared plus 8x plus 16. And you could follow what always happens in a problem like this. Simple here. If you have x plus 4 squared, you get the first term and then x times twice in this problem, right? I did the outsides here and the insides here. So So what might it look like on your homework? Well, let's look at this first example here. It says find the product, x plus 7 squared, that binomial. So again, if you know the pattern, here's all you'd have to do. Is x squared, 7 squared is 49, and when I take this pattern, that's going to happen twice. I put a little like 2 times that up there, and 2 times 7x would give me 14x. So there would be my answer. Using the pattern here. End of the problem here. And then t times 10 gives me 10t, and I'm going to get 2 of those. So 2 times 10t gives me 20t. And there's my formula. If you're looking at it and you're saying, oh, that shortcut looks a little quick for me, I'm still kind of figuring out where things. It is something actually just more you should realize over time how the pattern works. So you could still do FOIL method or table method for either of these and get the correct answer. But if you can see the shortcut pretty well, you can jump right to the last thing I want to show you, and I've kind of set up problems already. What happens when I have a subtraction sign? What if this is subtraction inside by a binomial? Now what's going to happen? How's the answer going to change? I'll usually ask classes ahead of time, what do you think is going to happen? And some can usually kind of figure it out. You're still actually going to have the same kind of pattern. And I could 5 times negative 5. So I still will get a it's still a very similar pattern. X squared gives me x squared. But now I have to think of this like negative 5, because I'd have negative 5 times negative 5. That would give me positive 25 here at the end of my problem still. My middle term, though, here's where the negative sign is going to play in. x, and I'll get 2 of those. So what I'll end up what happens when I have subtraction for my binomial? Well, all that happens is that middle term ends up being negative. And that's what I'd like you to write down here. I know this looks pretty similar to the one you already wrote down. But it is subtracting 2 terms. If you have a binomial I'm still going to get a squared on the front here. A times a gives me a squared. You'll still am getting b squared for the last term, but again, realize it'll be a negative times a negative, so that is why this still middle term is what will end up being negative, because you'll have a times negative again, and two of those, that's where that middle term will be negative. Showing it with this last example here. X minus 4 squared. So x squared gives me just that, x squared. Again, think of this like negative. And then the middle term will, so that'd be negative 4x, and you'll end up getting two of those in your pattern, just like with the previous one. And two of those will give me negative 8x. So whether you're adding or subtracting a binomial, and so if you had to use FOIL or tail method, you could still use those and get the correct answer. But here's a little